Hi, my name is David Tessar, and I'm a Senior Technical Evangelist at Microsoft here, and we are on Channel 9 Live at Ignite. I am joined by Taylor Brown. Welcome.
Hi, how's it going?
Great. Word on the street is that you know a little bit about containers and Windows.
Yeah, we've been working on containers for a while now. It's been one of the best projects I've ever worked on at Microsoft, and we're super excited to be able to actually show people what containers do and how they work.
Cool, yeah. So I think it would be good to just kind of level set, because there are still probably a lot of people out there who don't know what are containers. So
Yeah.
let's give a high-level quick view on what that is.
Yeah, I mean, so we've actually found that as we went to build and Ignite here, that folks just aren't aware of what containers are and what they mean for them. The easiest way for me to kind of think about it and explain it is, if you're familiar with a virtual machine pretends that it's hardware, and so we install an OS on top of it, and life is good. What containers do is they actually virtualize the operating system. They pretend that they're an operating system. So I can run an application inside of that, and I can have multiple apps side by side. They have no notion of each other. They're completely separated. They're in their own little world, completely unaware of the app next to them. And so we get a lightweight virtualization environment that still allows us to have that kind of nice application separation.
Okay, so I got to think about that IT guy out there who says, why should I care? Can I just go on my own way, keep it on with my virtualization, and have my full VMs and just forget about containers?
Yeah, I mean, you can, but I mean, what we're seeing is that, especially from the developer side, the flexibility they're getting out of it is just amazing, and that's translating right into IT. And so, the companies that are adopting containers and are using containers now, they're going from being able to deploy their sites once every couple of weeks to 100 times a day.
Yeah,
that's huge.
So spinning up, having that level of flow of innovation and that code moving forward 100 times a day, that probably becomes a little tough when you have full-blown VM images there, and not the containerization story. Yeah.
Right. And what was happening is people were deploying their entire site. So they were waiting until they had a huge set of things to do, and then they would deploy it all at one time. And so if it worked, that was great. You deployed the whole site, life was good. If it didn't, well, you rolled the whole thing back. With containers, they're doing change by change. So a lot of those rollouts are, hey, we fixed one file, we fixed a link, we fixed this one flow. And if it doesn't work, then we rolled back that one change. So we get changes out to customers faster. We have less big sets of changes and a much smaller iterative process. So it's really changed the way a lot of companies are working.
What about things like hardware? When virtualization first came around, you're like, well, my physical server is just not being utilized, and then came virtualization. Does containerization help with that utilization factor at all? Yeah. Yeah. There we go. So yeah, does containerization help with density and utilization and those kinds of things?
Absolutely. I mean, it's another form of virtualization, so it's doing much the same thing. But it's actually it's helping quite a bit. So you can get the same sort of density improvements out of virtualization or containerization that you would out of virtualization. So it's another tool in that toolbox.
Okay, very cool, very cool. All right, well, I know there's this concept that we've introduced of Windows Server containers and Hyper-V containers.
Yeah.
Maybe if you show the slide here, that might help for people. But what is the difference? Can you explain that a little bit?
So when we actually started looking at containers for the first time, our initial goal was to build something that looked a lot like what Linux had done with Linux containers, so that we could actually build a containerization into the operating system and run multiple applications and all of that. But we actually started looking at what people were doing with it, and in a lot of cases, they were running them inside of virtual machines because that was the isolation boundary that they needed. That was kind of what their compliance had. That's what their process was around it. And so they were having to go through the motion of spinning up a virtual machine just to run a container inside. And that's not a great process to go through. So we looked at kind of our bag of tricks, and we found that, hey, you know what? If we can just take care of that for them, so you set an extra flag, and we'll spin up the container inside of a virtualization boundary. We'll take care of doing all that for you. You just talk about a container and tell us you need to be isolated, and we'll do it. That was actually pretty powerful. And as we looked around our own internal workloads in Azure, we found that was exactly what we needed. Things like Azure Automation, we needed that extra layer of isolation. So when we run our containers there, we'll use Hyper-V containers. When we're building things out, we can use Windows Server containers. They're completely compatible with each other.
Okay. So you mentioned something that popped up here that's pretty cool. We're using, it sounds like, the Windows Server containers for, you mentioned Azure Automation Service.
Yeah.
Yeah.
We will be. We will
Okay,
be. Yeah.
will be. Okay.
Yeah. So certainly we looked around at all the things that we could use containers for, and sure enough, all throughout Azure, we found pocket after pocket of places that containers were really the tool that we needed to make that efficient.
Okay.
So our own internal needs predicated the need to build a container as well.
Okay.
So it's not just our customers, it's us. And I think that's generally true. When a customer needs something, most of the time, someone at Microsoft, we're just a big enough company that someone around us needs it too.
Mm-hmm. Okay. Another question that I think sometimes it comes up is this whole Nano server thing.
Yeah.
Well, can you run containers on Nano? Can you run containers on server core? Like,
right. So I mean, Nano's a really important part of the whole equation for us in the long run. So Nano kind of has two worlds. It's got a world as an infrastructure host, where it runs things like Hyper-V and it runs things like the file server, and it'll be a great container host as well. And then it's got a second world as a runtime operating system where I'm actually writing the next version of cloud apps on Nano server, right? Things that are using ASP.NET 5. Because it's the smallest operating system, and it's just enough to run those applications. So it's going to have faster containers to start up. Those containers are going to be smaller. That's going to be a great marriage. But we also recognize that we had a bunch of legacy applications that people had that wanted to take advantage of containers. And so we built Windows Server Core container support as well. So you get kind of whatever you need. You get as much operating system as you need for the legacy. And for more in the cloud applications, you can use that smaller footprint.
Okay, that makes sense. And would you ever want to run it on full-blown install of server? Would there be any use for that?
So, I mean, as if you've talked to Jeffrey at all, you know that UI is heroin.
Yeah,
right?
yeah.
It'll kill you. And so we really focus on server core and we focus on Nano server.
Okay.
And that's really where we're focused right now.
That's where it makes sense.
Yeah. I mean, that's the way that these server apps work. If you're talking about spinning up 1,000 containers and you're going to go click next on a whole bunch of
yeah, that's not going to work out so well.
Yeah.
No, you pretty much just can't go that route anymore.
Nope.
So maybe another thing that might be helpful is just talking a little bit about where can you deploy containers, because we're talking about a lot of stuff here. We got Nano server, server core, and then there's containers and two types of containers. Maybe just let's make it a little more practical on where that can go.
Yeah. Absolutely. So ultimately we can run containers on any, it'll be Windows Server 2016. So anything that's running Windows Server 2016, we can run a container on. Mm-hmm. So if it's a physical machine, like we've got here, we can spin up a virtual machine on top of that, and then we can run a container either next to that, or we can run it on top of the virtual machine. So really got a lot of flexibility. And so I think we've got one more in here that does that. But and the only place that we actually require a hypervisor is going to be with Hyper-V containers and with virtual machines. So if you want to run a Windows Server container, no hypervisor required. Okay.
So if you run it kind of on top of a virtual machine, does that mean that you have nested virtualization or something there?
That's exactly what it means.
Okay.
So we're building nested virtualization into Hyper-V exactly so that we can support running containers, Hyper-V containers, in virtual machines. So customers will be able to go get an Azure virtual machine and still take advantage of running Hyper-V containers with the isolation that they need for their workloads without having to worry about managing physical machines.
Wow, that's a pretty big deal, having that.
Cool.
Yeah, definitely. So you've got a lot of options here on kind of where to have those containers live.
And the most important part is that it's going to be, what we really want customers to do is go get a machine, whether it's a physical machine or a virtual machine, really doesn't matter. And then use the container technology that meets the needs of the workload. So if it needs to be an isolated workload, great, run a Hyper-V container. If not, a Windows Server container, you pick based on the workload.
Okay. So the next thing I was kind of wondering about is, these containers, like, right, we've got this flexibility and moving it around, and we kind of mentioned to the dev folks that they can run it on their box and things like that. But what are some of the things where dev and ops might work together in this new world, right?
Yeah, I mean, there's a bunch of areas where the collaboration is actually really important. So as we started talking to customers about how they wanted to use containers and what they thought about them, one of the places was the operations teams would build the kind of the operational layer. They would build kind of the first set of containers, and then the devs would build on top of that. The second area is kind of this operations pipeline. So as the developers finish with a revision and push it out to the operations team, it's up to ops to figure out how many instances do we need to run. Do we need it to be geographically dispersed? Do we need it to run in Azure? Do we need it to run on-prem? Do we need it to run a service provider? Where does this need to run, and how does it need to work? And then do all the tooling to get all the operations information out of it. Are we seeing high load? Are pages taking a long time to render? All of those kind of things, so that they can go back to the development team and say, hey, we really need to work on this. This page, it's got too many images on it, whatever that need is. And then the developers simply have to make a change, and those containers can get pushed right back out.
Yeah. And so, yeah, I think that point that you just mentioned there and the deployment aspect, how is that different or easier potentially now in this world?
I mean, there's actually a great story about this. So people who were paying really close attention during Mark's build keynote, there was actually a step in the Docker build, copied a file over, MSV CRT 120 DLL. So what was actually happened there is the whole website that we did for the build keynote had a dependency on a DLL that wasn't actually being published. But everywhere we were running it for build had Visual Studio installed, and Visual Studio happened to install that binary for us. When we actually went to deploy it to containers for the first time, the website wouldn't load. It wouldn't show up, wouldn't boot, because that dependency wasn't present there. If we'd actually been going to production with that website, it would have broken when we deployed it. Now, with containers, we had to fix that up front. We fixed the dependency. So when that website went to production, it worked the first time. It works every time, exactly the same way. Yeah. So you kind of get out of this world of, hey, it worked on my machine. I don't know.
Well, yeah, because these containers can be spun up in seconds, like seconds, and then you want to scale out to 100 of them.
Right.
Boom. You got them done.
And it runs the same way everywhere. So it's going to run the same on your laptop as it's going to run in pre-production, and testing, and production. Right. It doesn't have this kind of, well, if you installed it that way, then it'll work this way. If you installed it this way, well, maybe it'll work, maybe it won't. Right. We take the maybe out of it.
Yeah, that makes sense. Okay, very cool stuff. So the other thing that I'm kind of thinking about is the tooling ecosystem, because one of the things that we have is this whole, so far we haven't really talked about Docker.
Yeah.
Right? Which how do we relate? But Docker is a pretty big deal, and we've been doing a lot of work there.
Yeah.
The first high level question is, to run a Windows container, does that mean you have to run Docker or no?
No, it doesn't.
Okay.
So containers are a fundamental part of the operating system. We're building it into the operating system. Now, when we started looking at containers, there was something that was pretty obvious. The world liked Docker, right? Like that's what the development community liked. That's what they were using. So you know what? Like we're going to go where our customers are at. And so we started working with Docker. And so Docker's a tool set. It's used to create container images, it's used to manage containers, deploy containers, but we also are building an inbox PowerShell experience for folks who want to use PowerShell, who want a full Microsoft solution, or for whatever reason want to use something else. And we're doing all the work with Docker in the open, so anybody who wants to build a container management solution, go for it. We're more than happy to help them out and talk to them. The more the merrier.
Okay. Very cool. So the folks, the IT folks maybe that are out there who are comfortable with PowerShell, they can live there. They can just live there and spin up containers and do what they want to do in PowerShell and be happy.
Right.
But then for the Docker ecosystem folks who want to just natively use Docker commands, they're happy too, right?
Yep. Yeah. It's really about meeting people where they're at, right? Docker has done a fantastic job of kind of making containers a real thing for people. Containers have been around in Linux for a long time. Right. And it was the unicorns, it was the Googles of the world, and people who could develop actual solutions around it that could actually benefit from them. What Docker did is they kind of brought it to the masses. And that's where we want. We want everyone to be able to benefit from this technology.
So, what about, you mentioned Linux, right?
Yeah.
And so there's Docker, Docker has this kind of layer where you can use Linux containers and you can use Windows containers. Are those two interchangeable, or how does that work? Yeah.
Yeah, I mean, so if you've got an image that was built for Linux using Docker, that's got to run on a Linux machine. Now, it could be a VM that's spun up inside a Hyper-V or an Azure, but it has to have a Linux kernel there.
Yeah.
And the same thing will be true of Windows containers. So if it's built for a Windows container, it's going to have to run on an instance of Windows. Now, Docker's done some great things with like Docker Machine, where you can basically automate creating a VM, and they'll take care of all of the tooling. So, at some level, it almost looks like you're running Linux containers on Windows, because you're just running it inside of a virtual machine.
That makes sense. And so if you can run on IIS, right, you obviously can support a lot of different languages there.
Yeah.
So I guess that would mean that if you could, you have a Java app or something like that, and you want to run it on a Windows container, you'd be okay because the underlying Windows stack supports that.
Yeah. So we've already, just in playing around already, we've already got Minecraft up. So Minecraft needs all of Java.
That's the most important one right there. You gotta have Minecraft servers on containers.
Yeah, we pretty much pushed the keyboard back and just said done. Like, let's go home.
You checked it off. We're good.
We're good. Done.
Yeah.
We've got Node.js working.
Yeah.
Node.js to get that working was literally just a copy. We've got MySQL working. So just a huge amount of things that beyond just .NET. I mean, what's cool about .NET is if you're using .NET Core, you can compile that and run it on Windows and Linux. So you can see an experience where, in Visual Studio, I write my code and I say, try a Linux container. Great, now try a Windows container. Which one worked better? That's the one I'm going to deploy.
Okay.
But that's really a language statement.
Yeah, that's pretty cool. So the other thing, you mentioned Docker Machine. So Docker Machine, we can go and we can spin up, I'm assuming at a certain point, a Windows-based host to host containers. Okay.
That's our goal, yeah.
Okay. And then what about Swarm?
Yeah.
Why might somebody use that in this context?
Yeah. So there's two parts to Swarm. There's Swarm and Compose. And what Compose actually allows you to do is to say, my app is actually made up of multiple containers. Maybe it's a Linux container and a Windows container. I've got a MySQL backend that I'm using in Linux, and I've got an ASP.NET 5 application in Windows. But that's really what my app is. And then you hand that off to Swarm, and Swarm actually goes out and spins up all of those container instances for you. So it'll say, yeah, I know how to spin up 5 instances of that database, and I know how to spin up 10 web front ends, and I know how to scale those independently or scale them down. All of that work happens in Swarm. And we've actually done some work with Swarm already to call out to the Azure Resource Manager, all the new ARM stuff that we've been talking about this week. So it can actually create new VMs for you.
Wow, that's very cool. So then right from within Swarm, you could get that high availability clustering scenario on Azure or maybe on your own hardware on premises.
Yeah, or spanning.
Yeah, or spanning both. You got a lot of options there. I mean, that's where containers is really powerful in that workload mobility between cloud and on-prem, and basically as long as you're in that same stuff there.
Yeah, and that's the Azure stack, right?
Yeah.
That's the benefit we've got from all of that tooling across the whole thing.
Totally.
Yeah.
So you mentioned, one other thing earlier that I think is kind of important is isolation and security. Yeah. So, I mean, as an IT and ops guy, right? One of the big questions is, are these containers things secure? Can I count on them? And what does that mean? Is it more or less secure than Windows, right?
Yeah. I mean, so containers are it's a kernel thing. They are secure. Just as much as we say, yep, you can run different processes on Windows and that's secure. Containers are the same thing. If ever someone found a way to escape a container, that's a big deal. And we're doing a great amount of penetration testing to make sure that that's not possible. But at the same time, we also know that there's a lot of places, PCI compliance, if you're running credit card systems, where you actually have to have hardware virtualization. Like, that's just the requirement. And so we have that option for Hyper-V containers just to give us that extra layer of isolation. So that if someone ever did figure out a way around, there's another layer to block that. But we really think that they're secure all the way down to the kernel.
So I mean, would you say if you had to compare VM on Hyper-V to a Hyper-V container, kind of same?
Yep.
And in some instances, I'm almost thinking like if you're running a full-blown VM, just because of the sheer nature, if you've got a lot more running there, then almost like a container is probably in some way possibly more secure because you're running less on top of that, maybe?
Yeah, well, I mean, it's a management challenge. So you start to get into these scenarios where you've got thousands of virtual machines. You got to patch them. You got to make sure that they're running the right way. Malware didn't get on there. All of the just the challenges of running at scale. Whereas with containers, you build a new container image, you kill off the ones that you had, you start up new instances. They're always running the same way in the same environment. So it's much easier to kind of copy that out and make clones of containers and know that they've all changed. You're not accidentally forgetting one off to the side or something like that.
So yeah, so talk a little more about that process of patching, right?
Yeah.
So in VM world, you probably have a Windows Update server or a service or WSUS, and you've got this big thing, and it takes all this time. You have to do all these reboots and these things, right? It can be a pain for a lot of IT folks that are managing large data centers, especially. How is that different now with containers?
I mean, so part of containers is the actual instructions on how to build a container image. So Docker calls this a Docker file. We call it PowerShell. So you actually run through the steps to build a container, and what you say is starting from this point, like add this in, layer that on, set this as the command. And so when a new update comes out, if it's a major update, if it's a kernel update, we'll give you a new Windows container image, and you just run that file again and build a new container image on top of that. And so then when you actually run it, it'll just pick up the latest set of changes.
Okay. So you build the base image once, and then rolling it out because you've got these copies everywhere, and those instances can be killed and spun up in seconds, and there's other technologies around that to help with that load, right, to kill and bring them up.
Swarm and Mesosphere and all
Mesosphere and all these other ones to help with that. It's a different experience. It's you're patched after you spend a little bit of time to get that image that's patched, and then minutes or hours you're all rolled out and fully patched. Right?
Exactly.
Yeah.
And so one of the things we keep talking about is the image. The container image is what matters. Like that's the thing that matters now, because that's what's going to spawn the container. And so your job goes from I care about making a VM to I make a container image, and that's the blueprint for whatever I'm going to deploy. And so maybe you spend a little more time making that than you would just saying, there's a VHD, push it out. But then you're done. Job over. You can go home and you can be assured that you're not going to get that 3 a.m. phone call that, we need to, this is a problem, because you can just roll back if you need to.
Just roll back to an earlier version and you're good to go. Yeah, totally makes sense.
It's changing the way people are doing stuff.
Yeah. How, so that, we've kind of mentioned a few things, and I guess I kind of want to just maybe connect some dots for folks in the DevOps world. So you mentioned this Docker Compose, where there's this file that makes up your app. You talk about Docker Files, which makes up this base image. We also mentioned PowerShell, but all of those things, those are kind of like, this concept of infrastructure as code. Right? So you can go from zero to use these files, and you get the whole deal, right? So.
Yeah, there's kind of two worlds that are emerging. We've got this kind of DevOps world where you're actually writing the operations, you're checking it in, and things like Puppet and Chef and desired state configuration, and a lot of folks are adopting that, and they're doing great things with it. At the same time, we've got our kind of traditional operations roles where people are you're deploying stuff, and someone's sitting down in a room and drawing it out on a whiteboard. Those folks aren't going away. There's a lot of companies that are incredibly successful with that, and it's a myth. It works for them. And so while containers have this kind of DevOps feel to them, there's really is still an operation side of it too. Where people are building out services much the same way they were before, but using kind of the power of containers to make it easier and faster to do.
Well, yeah, and that's a common language, right? That both Dev and Ops can speak. It's like you have version controlled, checked in. You may have a central repository, right? In Docker Hub or other places where you have that code checked in to Visual Studio Online or wherever it is, and you all know you're on the same page, right? Of what that looks like when that latest build of that app, you can spin it up in minutes or seconds, and you're all happy, right?
And Docker's doing an enterprise, Docker Hub Enterprise, just for behind the firewall kind of scenarios.
Yeah. So there's this interesting concept, right? So of microservices.
Yeah.
And of course, a lot of people say, hey, if you're running containers, it's a great platform for microservices. Maybe just first at a high level, maybe just explain what is a microservice. You know, dev guys probably know a little more. IT folks may not. You may have heard the term, but what is that conceptually?
So a lot of people talk about it in different ways. For me, I look at a microservice as it's just the basic component to do an operation. So it's the one set of code that's going to be necessary to maybe convert an image from something, or to insert a record into a database. And what you actually do is you scale those out. So when I actually need to run a website, I may be running a lot of instances of that one piece of code, but they're all kind of isolated from each other. And then you connect all those services up together and you've got an application. And there's a lot of ways where that lends itself to containers. People are doing much the same thing with containers. It might be that you, down the hall, you're running part of the app and you're building a container, and I'm using your container as part of the web front end, and then this guy down the hall that's got the web service part of it. And so that's kind of looks a lot like a microservice at some level.
Okay.
But you know, containers are a little bit larger than what generally people think of a microservice.
Yeah.
Things like Azure Service Fabric really exonerate what a microservice truly is, where you write your code and you plug it into the framework, and the framework takes care of it all for you.
Okay, so yeah, can you explain a little bit about that? Because I think it's important, you know, from folks because, you know, I'm guessing a lot of folks probably don't already just fully running Docker everything, right? And obviously this new Service Fabric thing we announced, I mean, we've had PaaS for a long time, now we have the Service Fabric, is a totally new thing. So when you're looking to kind of make some investments in updating your app architecture, you've kind of got this container thing, and you've got this Service Fabric and PaaS thing. So what are some of the trade-offs or reasons why I might want to use one versus the other?
Yeah, I mean, so actually at some level, you know, Azure Service Fabric is they're planning to fully take advantage of containers as well. So if you're writing your code to Service Fabric, today that's running one way. Tomorrow that might actually be using containers, but you don't have to care. Like basically you're giving it to us, we got your back. We'll take care of running it in the right way. Maybe that's in a VM, maybe that's in a container. We'll take care of it. If you want to write to containers, that's fantastic. Like, great, you can use containers, or you can use it all together. So we know people already are looking at using Azure websites for their front end. They're looking at using Azure Service Fabric for middle tiers, for web services and things like that. They're looking at using containers for some of the processing, and Azure Database for the back end. So they're using all the tools we're giving them to make their application work in the way that they see best, right? And my gut is that they're going to play around with some of that stuff, and they're going to say, you know what, I really like Service Fabric. It does exactly what I need it to do, and so I'm going to use it for some of the other parts of my application too. Okay. And it's going to take advantage of containers where it's necessary, and it's going to take advantage of other technologies where those are important.
So we're really enabling you to take the best of breed kind of approach. So maybe for Service Fabric, if you don't want to have to deal with the high availability hosts, the clustering, the fault, failover, all that stuff, you just kind of want to easy deploy it and let Azure do all that special sauce. Then that's one option. But then if you want to maybe merge that in with containers, and you kind of got those options for yourself.
Yeah,
I see.
It's the best of both worlds, right?
There you go.
Let people make the choices that make sense for them. Yeah. You pick the language that works best for you, pick the framework, pick the technology. We think virtual machines, people are going to continue to use virtual machines for a lot of things for a long time. It's the right tool for the job. Containers are just a new tool in that toolbox for people to use. Cool.
So where would you say, what are some good first steps maybe for folks that might want to get started? They haven't done anything with containers and Docker or anything else. What are some things you might recommend for them to kind of get going?
I mean, so we've got a great site, aka.ms/Windows Containers, and that links off to our new documentation site, which is actually on our new documentation platform. It's all written in Markdown, so we're actually iterating on that really quickly as well. And we've got a lot of links out to kind of basic questions. What is a container? Where would I use a container? What are we doing with Docker? We've got some great FAQ around that. And then what I'm telling people right now is if you want to get a head start before we have our preview available this summer, go start playing with Docker a little bit. We've got a great, it's in the gallery. You can spin up a Docker VM straight out of the Azure gallery. Yeah, go play with it a little bit. Deploy a WordPress site. Take a swing at that. The same commands you run in Docker today are going to work in Windows containers this summer when we got to build for you.
Okay, all right. Thanks so much, Taylor, for your time. And if you folks have other questions, feel free to comment below here on this Channel 9 post. We'd love to hear from you.
Yeah.
Thanks.
Thanks.